So, hello guys, this is gonna be like a quick tutorial kind of thing where we're making a vector class in Python. So, this will not be like a production ready vector class kind of thing, but the scope of this video is more to sort of highlight how you could use already existing classes or objects in Python and namespace them, or subclass depending on what you want to call it, and overload the operators that could act on them to make it a bit more convenient to work with, so to speak. So, starting off here, we are using the native array class in Python, which, for my surprise, a lot of people don't actually know that Python has a native array class because people just use NumPy. But yeah, anyway, and we'll also be bringing in the square root for obvious reasons. So we're dealing with vectors. Okay, so now we will create this class vector that inherits from this array. So I mean, there's already an array class, so there's no need to reinvent the wheel. Okay, so basically what we're going to be doing is overloading the operators that can act on it. First we start with multiplication. Basically we overload this such that if the second one is also a vector, we return the dot product, which is basically like the elements, an element-wise multiplication and then summing across all the components. Or else, if the other argument is an integer or a float, we just scale the vector. So basically, that's very simple. Now here we have the armul. This is the same as the multiplication operator, but it overloads to in this case, we're overloading it to allow for commutativity. So if we don't put this here, we will be able to do a vector times 2, for example, but we won't be able to do 2 times a vector, which from mathematics should be the same thing. So that's why this method is here, to basically tell it, yes, the direction doesn't matter, both are the same. So next, we overload the addition operator, and for this we are only concerned with if other is a vector. So basically, if we have v1 plus v2, we get a new vector. So we just add everything element-wise. We overload the negation operator, which basically returns the itself multiplied by -1. This would allow us to do stuff like, for example, minus v, and it will know how to interpret that. We overload the subtraction operator, which basically combines the addition operator and the negation operator into one neat little package here. We overload the division, which is basically the multiplication operator acting on the inverse of the scalar value. We overload the absolute value function to return the length of the vector. And just for fun, we overload the print statement, which is the conversion to string of the vector, to be a list of the components and the data type, because the array class is how do you say, homogeneous in terms of data type. You can't have like lists, whatever you want in there. They have to be the same data type basically. And here, for fun, we add this norm attribute. Well, it's a method really, but this decorator makes it behave as though it was an attribute, and basically this returns the normalized version of the vector, so to speak. So now to test this, we put it in an if name equals main scope. This is mainly so we could like import this class into, say, a different script and use it without having to go through this chunk of code, because at that point, if it's imported, then the name wouldn't be main for Python. So we initialize a vector as a float vector with these components, and then we test multiplication, scaling on both sides, addition, subtraction, and yeah, division would actually let's do division. Okay, the absolute value and the norm, which, as you can see, even though it's a function, we could call it like this. So let's also do some more printing here to make things even more clear. So now we know what each output is doing essentially, and actually let's put some separations here. Okay, so now let's give it a try. Okay, so this is our vector 1 1 1. If we multiply, we take the dot product of this with itself, we get 3, which is correct. We scale it by 2 on both sides, is correct. Halve it on both sides, have it on the back side. You can't really halve on both sides because the division is not commutative. It's correct. V plus V is correct. V minus V is correct. The absolute value of V seems correct. Yeah, sure. And the normalized vector of V is correct. And this is like our print statement, which is like a list of all the elements and the data type that we decided to set as our print statement when we do print V. So yeah, that's pretty much it. Thanks for watching. I hope you found this somewhat informative and concise enough to be useful, and I'll see you next time. Bye bye.